Okay, good morning, class. Today we are still want to continue with differentiation, but this time we are moving to rules of differentiation. Yeah, page 24. So we're actually moving to rules of differentiation. Then a brief revision of what we did last class. And the last class, I introduced differentiation as a topic. I said differentiation means the rate of change of a variable with respect to another variable. If y is expressed as a function of x, let's say y is equal to x raised to the power of n, then we can differentiate y with respect to x because y is a function of x. So the differential of y with respect to x, which is dy over dx, I give you two steps. The first step is that you bring down the power, which is n, subtract 1 from that power. And so this is what we call the power rule. And it is applicable to differentiation of polynomials. Then the assignment I gave you, you will not be able to submit now. At the end of this class today, I'll give you the email address where you are going to submit the assignment. So the assignment is still on. You can still do it and submit at the appropriate time, which I will tell you at the end of this class. So now under rules of differentiation, we want to check three basic rules of differentiation. The first one is called the chain rule. Chain rule. Yeah, that's to say you have chain rule. Yeah. That's the first one. Chain rule, or you can also call it function of a function. Function of a function. That is another way to express chain rule. And now to get chain rule here. If y is a function of u, for instance, if you have y is a function of u, and u now is a function of x, it means y is not directly a function of x. Y is a function of u, and u is in turn a function of x. It means y can only be differentiated with u because y is a function of u. You cannot differentiate y with respect to x directly. You have to go from y to u first, and then you can get du or dy over du. That's a differential over du. Then u in turn is a function of x. That means you can differentiate u with respect to x. That means here you can get du over dx. Then how do you now get function of if y as a function of x? It means therefore dy over dx here should be equal to dy over du times du over dx. And that is what we call it a chain rule. You are bringing two functions together. Y, which is a function of u, you differentiate to get y dy over du. U, which is a function of x, you differentiate to get du over dx. So then what is now dy over dx? It is dy over du times du over dx. This is what we call the chain rule of differentiation. And of course, it is applicable to complex functions. This slide will be given to you. You copy that, but let's see how to solve question on this. So it is chain rule and it is applicable to complex functions. So let's see examples here. The first question here. So differentiate the following functions. And the first one, you are given y is equal to, that is the example. Number 1. Y is equal to the square root of 1 minus x raised to the power 3. 1 minus x raised to the power 3. And of course, here, what you have under the square root is 1 minus x cubed. And that means 1 minus x under the square root again makes it to be a complex function. It will be easier for you if you use chain rule in this instance. You can bring in another variable, let u equals that expression under the square root. And that u is equal to 1 minus x cubed. I've made u now to be a function of x. Meaning that you can only differentiate u with respect to x. So that means you can get du over dx. And don't forget the two steps I gave you when you are differentiating. First, one is a constant term. It is a constant term because it does not have ux at all. No letter is attached to it. Whether x is increasing or decreasing, one remains the same. That's why I say it's a constant term. So now to differentiate the minus x cubed, 2 steps. Bring down the power is 3. 3 times minus 1, that will give minus 3. Then subtract 1 from that power. 1 from 3 will give you 2. So that means the differential of 1 minus x cubed is minus 3x raised to the power of 2. Then, since I have made this one to be u, it means y now, the square root of u. Because what we have under the square root sign has been named u, which is meaning that we are breaking down the expression to make it simpler. Remember I said it's applicable to complex functions. So then from law of indices, if a number is under the square root, the number raised to the power of 1 over 2. That means it is u raised to the power of 1 over 2. Then since y is a function of u, I can now differentiate y with respect to u. It means that the y over du is equal to, so again, 2 steps. Bring out the power, that's 1 over 2. Subtract 1 from the existing power. 1 over 2 minus 1. Of course, 1 is bigger than 1 over 2. So if you subtract, you are going to get a negative answer. So that is 1 over 2. U raised to the power of minus 1 over 2. This is SS3 class. You should be able to subtract 1 from 1 over 2. That is here. Just have 1 over 2 minus 1. That one can be written as 1 over 1. So the LCM is 2. 2 divided 2 is 1 times 1 will still give you 1. Minus 1 divided 2 will give you 2 times 1. That is 2. And of course, 1 minus 2 will give you minus 1. So it's minus 1 over 2. So that's how I got the power to be minus 1 over 2. So it means now this is going to give you 1 over 2. Then u raised to the power 1 over 2, which is 1 over 2 root u. Okay. 1 over 2 root u. So from here now, bring in the values. Okay? We have our dy over dx is equal to dy over du times du over dx. So substitute dy over du here, it is 1 over 2 square root of u times du over dx, you check it, this is minus 3, x raised to the power of 2. And so that means this becomes minus 3 over 2, x squared over 2 root u here. Minus 3x squared over 2 square root of u. Your answer cannot be left like this because you brought u in. You have to change, substitute again. The value of u should come in. Don't forget from here. U is 1 minus x cubed. And that means our dy over dx now is equal to minus 3x squared all over 2 square root of 1 minus x cubed. And that is, if you check the solution, that's how we got to this point. Because this is 3x cubed minus 5x. That is exactly what you have inside the bracket. So that means u is now a function of x. I can only differentiate u with respect to x. So I can get du over dx. Again, 2 steps. Bring down the power to multiply and subtract 1 from the existing power. 3 times 3 will give you 9. 3 minus 1 will give you 2. That's 9x raised to the power 2. Then, of course, the power of x here is 1. So 1 times minus 5 is minus 5. And that is raised to the power of 0. And, of course, you agree with me that x raised to the power 0 is just 1. So it's just 5 here. So the du dx is equal to 9x squared minus 5. Then, since this bracket is now u, that means y is now expressed as u raised to the power of minus 3. Because the expression inside the bracket is u. So then, since y is a function of u, I can differentiate y with respect to u. So I get dy over du. Again, bring down the power, you have minus 3. Subtract 1 from minus, that will give minus 4. Minus 3 minus y is minus 4. So that means this is going to give you minus 3 over u raised to the power of 4. So this is dy, yes, dy du, and this is our du dx. So then we can use our chain rule. Our dy over dx is equal to dy over du times du over dx. So you substitute. Then we have this. Let's put it the other side of the board. Yeah. So our dy over du is here. Minus 3 over u raised to the power of 4 times our du over dx, that is 9x raised to the power of 2 minus 5. And of course, this becomes, this is the next step. So this is going to give you now minus 3 into 9x squared minus 5 all over u raised to the power of 4. And of course, u is equal to 3x cubed minus 5x. And that means the answer is minus 3 into 9x cubed, 9x squared rather, minus 5 all over 3x cubed minus 5x all raised to the power of 4. And that means this is the answer there. There's no point removing the bracket here. You can leave the answer in this form. And that is that about chain rule. The next rule under differentiation that we're going to check is what we call the product rule. Of course, product means the outcome of multiplying a number or a term by another one. The outcome of multiplication is product. So if a function is given such that it contains products of two expressions, let's say you are given this, so product rule now. Product rule. We have this. If y is equal to u times v, where u and v are functions of x, that means I can write that the y is equal to u of x times v of x. So y is the product of u and v. That does not differentiate y with respect to x. Then the differential of y with respect to x, which is dy over dx, is given by this rule, which is called the product rule. That is, you keep a function, a term, and differentiate the other one. I can keep u, then differentiate dv dx. Differentiate v rather with respect to x, that will give dv dx. So that's u dv dx plus. Then now you change, keep v this time, and differentiate u with respect to that will give du dx. So that means this is the y dx is equal to u dv dx plus v du dx. This is what we call the product rule. And product rule is used in differentiating expression involving product of two terms.
Use your speed, sir.
Okay. So product rule is used in differentiating function involving product of two terms. And that's why we say if u is equal to, if y is equal to u dot v, this dot term means multiplication. You are multiplying u by v, where u and v are functions of x. So if you want the formula is dy over dx is equal to u dv dx plus v du dx. Of course, dv dx means the differential of v with respect to x. Du dx means the differential of u with respect to x. Just pick one of the terms or the expression to be u. Automatically, the other one becomes a v. So now let's see examples there. Examples. So differentiate the following with respect to x. And the first one, we are given this y is equal to x raised to the power of 5, then brackets open, 2x plus 1 raised to the power of 3. So if you check, this is x raised to the power 5 multiplying 2x plus 1 all raised to the power 3. So x raised to the power 5 is a function of x. 2x plus 1 raised to the power 3 is also a function of x. And this is product of these two functions of x. And that means the product rule is applicable to this function, to this expression. The question is I should differentiate y with respect to x. So I can start by saying let u equals x raised to the power 5. So the first expression of the term has been labeled to be u. Since u is a function of x, I can differentiate u with respect to x. So I'll get du over dx. Du over dx. Of course, don't forget 2 steps. Bring down the power of x, subtract 1 from the existing power. The power of 5, x is 5, so bring down 5. And subtract 1 from that, that will give you x raised to the power 4. So that means du over dx is 5x raised to the power of 4. Definitely, the other term there, the expression there becomes a v. So it means, and v is equal to 2x plus 1, all raised to the power of 3. Yeah. So that means v is now expressed as 2x plus 1 raised to the power 3. So we can differentiate v with respect to x. So dv over dx, again, bring that down here. You check here, we are going to apply chain rule here. Differentiate the bracket as a whole. Then differentiate the expression inside the bracket separately. This 3 comes down, that will be 3. Then you have 2x plus 1. Subtract 1 from the 3, that will give you 2. You are not going to stop there. Then differentiate what you have inside the bracket separately. The bracket is 2x plus 1. So the differential of 2x plus 1 will give you 2. Yeah. Because 1 is a constant. So you can, differential of a constant is 0. These 2 multiplies this 3, and that means dv over dx is 6, bracket 2x plus 1 raised to the power of 2. Yeah. Then we've been able to get an expression for du over dx. We'll get another one for dv over dx. Then we can now apply the formula. The product rule is applicable in this instance. So we have this. Our product rule again, dy over dx is equal to u dv over dx plus v du over dx. And of course, it can also be v du dx plus u dv dx. You know, addition is commutative. Anyone can come first. Yeah. So that means then substitute u here. Our u is x raised to the power 5. This is x raised to the power 5. Then dv dx, our dv dx is here 6 into 2x plus 1 all squared. Then plus our v 2x plus 1 raised to the power 3 times du dx. Our du dx is 5x raised to the power of 4. Yeah. Then now, if you open this bracket, that's going to give you 6x raised to the power 5, then 2x plus 1 raised to the power 2, plus 5x raised to the power 4, then 2x plus 1 raised to the power 3. Then let's see, 2x plus 1 square, 2x plus 1 cube, x raised to the power 5, x raised to the power 4. We have common factors. X raised to the power 4 is common. Then 2x plus 1 raised to the power 2 is also common. And now if you check here, you have x raised to the power 4 can divide x raised to the power 5. You can also divide x raised to the power 4. That means it's a common factor there. Then 2x plus 1 raised to the power 2 means 2x plus 1 in 2 places. 2x plus 1 raised to the power 3 means 2x plus 1 in 3 places. So 2x plus 1 in 2 places is the highest common factor there. So that means our factors are this. If I remove 2x plus 1, x raised to the power 4, 2x plus 1 square here, you have only 6x remaining here. Plus, this is 5 into 2x plus 1. And that means this is going to give you here, this is x for 2x plus 1 squared, then 6x plus 10x plus 5. 5 times 12 will give you 10x, and 5 times 1 is 5. And that means this is now going to give me x raised to the power 4, 2x plus 1 raised to the power 2, and 16x plus 5. Even if you leave the answer like this, you are still right as well, but this is better. Okay. Now, the product rule again, we say product rule is applicable to functions involving product of two terms, preferably functions of x. So like you are given y is equal to u of x times v of x. This means a u of x is multiplied by v of x, and this is product of the two terms. To find the y, to get the differential of y with respect to x, you are going to use what we call the product rule. And this is the product rule. dy by dx is u dv over dx plus v du dx. And this keep u, differentiate dv, v with respect to x, then change the approach plus keep v this time, differentiate u with respect to x. And like I said, addition is commutative. This it can be dv v over v du dx plus u dv dx. So come first. So that means here, what I'm saying is this formula can also be equal to v du dx plus u dv dx. So this can come before this u dv dx. And now, how do you know when to apply this formula? It is only when you are given functions or expression involving product of two terms. And that's what you are given here. The first example, y is equal to x cubed, x raised to the power 5, then brackets open 2x plus 1, all raised to the power 3. It means x to the power 5 is being multiplied by this second bracket, which is 2x plus 1 raised to the power 3. Then make any of them to be u, and then definitely the other one becomes a v. So I started with the first term. Let u equals x raised to the power 5. U means u is equal to x raised to the power 5 means u is a function of x. you can differentiate u with respect to x. And that means now if you differentiate, you have 5 x raised to the power 4. That is u, now du over this is 5 x raised to the power 4. Then definitely now, this second term becomes v. Our v now is 2x plus 1 all raised to the power 3. So that means now to differentiate this, it looks a bit complex. It is either you first expand, which is not feasible in this case. You can use the chain rule. Bring down the power of 3, subtract 1, and differentiate the brackets separately. When you bring down the power of 3, that is 3. Subtract 1 from 3, that will give you 2. So that's I got 3 into 2x plus 1 raised to the power 2. When you differentiate the brackets, what you have inside the bracket is 2x plus 1. The differential is 2. So then that means this is 6 into 2x plus 1 raised to the power 2. So this is what we call dv dx. So this is our du dx. This is our dv dx. There. So okay, if you now use the formula is this. Our dy dx means u dv dx plus v du dx. Then just substitute. You already got, this is our u, this is our du dx, this is our v, this is our dv dx. That means you have all you need. Just substitute now. So our u is this, x raised to the power 5. This is u, x raised to the power 5. Then dv dx is this, 6 brackets open, 2x plus 1 raised to the power 2. Plus our v is this, 2x plus 1 all raised to the power 3 times du dx. Our du dx is 5x raised to the power 4. Then you can, then if you now bring this together, 6 comes out. You have 6 into x raised to the power 5, then 2x plus 1 squared, plus 5x raised to the power 4, then 2x plus 1 all raised to the power 3. If you stop here, it's okay. But you can go further because you can still simplify further. So if you check it now, this is x raised to the power 5, x raised to the power 4. The highest common factor now is x raised to the power 4. The one that factor means the non-term that will divide each of them without a remainder. If you pick x raised to the power 5, it will not be able to divide x raised to the power 4. So that's why we are picking x raised to the power 4. Because it will divide x raised to the power 5, it will as well divide x raised to the power 4. Then 2x plus 1 raised to the power 2, 2x plus 1 raised to the power 3. Then the common factor there is 2x plus 1 all raised to the power 2. So I factorize out those two common factors. This is x raised to the power 4, then 2x plus 1 all raised to the power 2. If I remove x raised to the power 5 from here, so x raised to the power 4, you have x remaining. With this 6, that's I got 6x. If I remove this 2x plus 1 squared, this is also gone. And that means you have only 6x remaining here. If you remove x raised to the power 4 and remove this x raised to the power 2x plus 1 raised to the power 2, you have another 2x plus 1. And that's now you have 5 into 2x plus 1 remaining. Then here you can remove the bracket. That means this is x raised to the power 4, 2x plus 1 all raised to the power 2. This is 6x plus, then remove this inner bracket. 5 times 2x will give you 10x. 5 times 1 will give you 5. And so now you have x raised to the power 4, 2x plus 1 all raised to the power 2, then dot 6x plus 10x plus 5. And that means 10x plus 6 will give 16x. And that means this is the final answer. X raised to the power 4 bracket, 2x plus 1 raised to the power 2, then another bracket 16x plus 5. Or it can still be x raised to the power 4, 16x plus 5, then 2x plus 1 all raised to the power of 2, which is the final answer there. Then the next rule. Okay, that's example number 2 under product rule. Example number 2 under product rule. You learn mathematics by solving questions. That's why we are given enough examples so that by the time you solve questions on your own, you have examples to follow. So example number 2, you are given y equals, this is the square root of x plus 2, then times the square root of x plus 3. And of course, if you check it, it means the product of a particular term, a function of x, by another function of x. You don't need to be told that you have to apply the product rule here, because this is product of two terms. Again, make one of them to be u, and the other one becomes v automatically. So if this is my u, this is v. I'll start now. Let u equals the square root of x plus 2. Okay. From law of indices, when a number is under the square root sign, it becomes the number raised to the power of 1 over 2. So that means this u can still be written as x plus 2 all raised to the power of 1 over 2. Then, since u is a function of x, we can differentiate u with respect to x. So du dx is 2 steps again, don't forget. Bring down the power, subtract 1 from the existing power. So if you bring 1 over 2, you have here 1 over 2. Then this is x plus 2. Subtract 1 from 1 over 2, that's 1 over 2 minus 1. And this becomes 1 over 2, then bracket, x plus 2 raised to the power of minus 1 over 2. There. But because this power again is a negative, from law of indices, when a number is having a negative index, it becomes the reciprocal of the number raised to the positive index. If you have a raised to the power of minus 2, it becomes 1 over a raised to the power of positive 2. And the same thing is applicable here. So our du over dx is going to be 1 over, this 2 is already here. This is x plus 2, all this for positive 1 over 2. And that can still go further as 1 over 2, the square root of x plus 2. This is our du over dx now. This is du dx. Our du over dx is this. So let's keep that. Then, of course, we need dv over dx as well. So the second function of x there becomes v. So this is v is equal to the square root of x plus 3. The same method I applied in the first one, express it to have a power, so it becomes x plus 3 raised to the power of 1 over 2. Then to differentiate, bring down the power, it means our dv over dx, yeah, is equal to 1 over 2 x plus 3 raised to the power of minus 1 over 2. Then, and this is going to be 1 over 2 square root of x plus 3. So that means this is our dv dx. So this is dv dx now. dv over dx is this. Then the formula now comes in. The product rule again, dy over dx. Keep u, differentiate v. So u dv dx plus. Then reverse the process, keep v, differentiate u, v du over dx. Yeah. Then substitute. U is here, this, root x plus 2, times our dv over dx is this, 1 over 2 root x plus 3. Then this, plus, then v, our v is this, root x plus 3, times our du over dx is here, 1 over 2 root x plus 2. Then, of course, if I have 2 multiplying a over 3, I can simply write as 2a over 3. So meaning that this 2 is multiplying 1 over 2 root x plus 3. So it can simply be written as root x plus 2 all over 2 root x plus 3 for the first thing. Then the same thing is applicable to the second bracket. This becomes root x plus 3 all over 2 root x plus 2. So we're having 2 fractions now. This is addition of 2 fractions. Of course, the usual thing that you find the LCM of the denominators. And of course, yeah, these are algebraic fractions. So the LCM becomes 2, then the square root of x plus 3, then x plus 2. From the laws of surd, when you have root a times root b, you can bring them under the same square root. So it can be square root of ab, and that's what is applicable, what I did here. So you can bring the 2 of them under the same square root. And that means now, if you divide this LCM by the denominator, 2 will divide 2 out, root x plus 2 will divide root x plus 3. That means root x plus 2 will remain here, which has to multiply root x plus 2. This is square root of x plus 2, multiplying another root x plus 2. Then, the same thing at the other side here, the denominator is 2 root x plus 2. If you divide this LCM by 2 root x plus 2, 2 will divide 2 out. Root x plus 2 will divide root x plus 2. That means you are left with root x plus 3, which will multiply another root x plus 3. Then, again, I will take you back to surd. If I have the square root of 2 times square root of 2, that's just 2. Root a times root a, that is just a. And the same thing is applicable here. Root x plus 2 times root x plus 2 just give you x plus 2. And this is plus. Root x plus 3 times under root x plus 3 will give you x plus 3. And that means you are now having this to be over 2 square root of x plus 2, then x plus 3. So it means this is going to give you x plus x will give you 2x. 2 plus 3 will give you 5 at the numerator. Then the denominator still remains 2 root x plus 2, then x plus 3. The 2 under the same square root sign. And that is the answer. Yeah. Again, I want to re-explain this. The question given to you is this. Y is equal to root, I started this. Y is equal to root x plus 2 times root x plus 3. Root x plus 2 is a function of x. It's being multiplied by root x plus 3. You check, I told you earlier that product means the outcome of multiplying a term, a number, by another one. And that is what is playing out here. Root x plus 2 is being multiplied by root x plus 3. So the best method that you can apply is the product rule. To apply the product rule, you have to label one of the functions of x to be u. Definitely the other one becomes a v. And that's why I put u to be root x plus 2. Then I told you that from law of indices, if a number is under the square root, then the number, it becomes the number raised to the power of 1 over 2. If it's under the cube root, it becomes raised to the power 1 over 3, and so on. All this you have been taught in the previous classes, even in the accessory class as well. So that means this root x plus 2 becomes x plus 2 raised to the power of 1 over 2. And of course, to differentiate, don't forget the 2 steps I told you. Bring down the power of x, subtract 1 from the existing power. So the power that you have here is 1 over, so bring down the 1 over 2, that's the 1 over 2 you have here. Subtract 1 from 1 over 2. 1 is bigger than 1 over 2, and once you subtract, get minus 1 over 2. So you have 1 over 2 square root, sorry, 1 over 2 bracket, x plus 2, all raised to the power minus 1 over 2. Then, again, the law of mathematics, the topics are interrelated. We are using lots of indices often here because you have been taught. So now, when a number is having a negative index, for example, you have a raised to the power minus n. It's going to be the reciprocal. That means 1 over a raised to the power positive n. And the same thing is what I did here. This now 1 over 2 is on its own. So this becomes 1 over, the 2 is already at the denominator, then x plus 2 raised to the power positive 1 over 2. Again, x plus 2 is having the power of 1 over 2. So it goes to the, it becomes the square root of x plus 2. So du over dx is equal to 1 over 2 square root of x plus 2. This is du dx. This is our u. Then, definitely this second term now becomes v. That's why I say v is equal to root x plus 3. Again, go through the same process there. That will give you x plus 3 raised to the power 1 over 2. To differentiate, bring down the power, subtract 1 from the existing power. So 1 over 2 is there. You subtract 1 from 1 over 2, that will give minus 1 over 2. And apply that law of indices, dv over dx will be 1 over 2 root x plus 3. There. So that means we have our u, we have our du dx, we have our v, we have our dv dx. That means we have everything we need in order to solve this question. So again, this question, the product rule, the 1 over dx is equal to u dv dx plus v du dx. Substitute now. U looks our u, root x plus 2, times dv dx, our dv dx is here, root 1 over root 2 root x plus 3. That's for the first term. Plus v, that's our v, root x plus 3, times our du dx, this is our du dx, 1 over 2 root x plus 2. And I told you if you are multiplying a number by a fraction, the number only multiplies the numerator of the fraction. That's when I gave you this illustration here. 2 times a over 3 is 2a over 3. The same thing, root x plus 2 times 1 will give you root x plus 2, all over 2 root x plus 3 here. Then plus root x plus 3 times 1, that will give you root x plus 3, all over 2 root x plus 2. So we are adding 2 fractions now. The usual thing that you find the LCM of the denominators. The denominators are 2 root x plus 3, and here 2 root x plus 2. So the LCM is 2, the square root of x plus 3, x plus 2. And I told you, from law of surge, when you have root a times root b, you are allowed to bring them under the same square root sign. So you can write as square root of ab, the same under the same square root sign. So that is what I did here. So you have 2 root x plus 3, then x plus 2. So if I divide this LCM by this square, the denominator, 2 will divide 2 out, root x plus 2 divided root x plus. That means I will be left with root x plus 2, which is this, multiplying the numerator, which is under root x plus 2. Plus the same thing here. You divide this LCM by this denominator. 2 divide 2 out. Root x plus 2 divided root x plus 2. That means you are left with root x plus 3, which is this, multiplying this numerator under root x plus 3. Then I said square root of a times square root of a will give you a. Just is, if you use number, root 2 times root 2, that is root 4. And root 4 is 2. So instead of going through this stress, just root 2 times root 2, just bring out the 2 under the square root out. If you have root 3 times root 3, just write as 3. Root 5 times root 5, just write as 5, and so on. And that is what I did here. Root x plus 2 times root x plus 2 is just x plus 2. And here, root x plus 3 times root x plus is just x plus 3. So that means at the numerator, I have x plus 2 plus x plus 3 all over 2 root x plus 2 x plus 3 under the same square root sign. Now, of course, at the numerator, we call it like terms. X and x are alike. So x plus x will give you 2x. 2 plus 3 is 5. That is 2x plus 5 all over 2 square root x plus 2x plus 5. That is the final answer there. Then, the last rule we want to check is what we call the quotient rule. Like I said earlier, all this you are going to copy later. You don't need to at least write the solution now. It will be given to you on the YouTube. So the last rule we want to check is the quotient rule. Quotient rule. Quotient is the outcome of dividing a number or a term by another one. For instance, if I divide 6 by 2, I'm going to get 3. That means the quotient of 6 by 2 is 3. So here we have quotient rule. Quotient rule, like I said, is applicable to fractional expressions. If I have y is equal to u over v, of course, you know v must not be equal to 0. If v is equal to 0, it becomes an undefined fraction. Any fraction that's having the denominator being equal to 0 is an undefined fraction. Undefined means it doesn't have a value at all. So the denominator must not be equal to 0. So then u and v are functions of x. Then the rule is this. It says if you are having y to be u over v, where v is not equal to 0, then the y dx is this. That's the differential of y with respect to x. If this is u of x, v of x as well. So it means the y over dx is equal to v du dx minus u dv dx all over v squared. And this is what we call the quotient rule. Quotient rule is applicable to fractional expressions. Whenever you are given a fractional expression to to differentiate, then apply the quotient rule. So that's why I say if u over v, if u is equal to y is equal to u over v, where u and v are functions of x, and v is not equal to 0, then the derivative of y with respect to x is given by this formula. That is the formula of, and that is called the quotient rule. And I said the quotient rule is applicable to the differentiation of a fractional expression. So let's see examples now. Examples. So it's differentiate the following. You are given y is equal to, this is x plus 2 over x plus 1. X plus 1. And here, please, when you are given y is equal to u over v, the numerator must be equal to u, unlike the product rule where you can just choose any of the functions or the terms to be u, and the other one becomes v. In quotient rule, numerator is u, and the denominator is v. There. So that means in this particular question here, the numerator is u. Our u is this. Let's u is equal to x plus 2. And our formula, we need the u over dx. So u is a function of x, meaning that you can differentiate u with respect to x. So that means the u over dx is equal to 1. And of course, 2 is a constant. The constant term is 0. I said that more than 100 times. So that is the only one we are differentiating is x. This x can be written as x raised to power 1. If I bring 1, then this is 1, then subtract 1, that is 1 minus 1. And that means this is going to give you 1, x raised to power 0. X raised to power 0 is 1. So that's 1. So that means here, this is just, so that means this is 1. So the differential of u with respect to x is 1. That's u by x is 1. Then check, I said this is u, the numerator u. and the denominator is v. So that means definitely what you have at the denominator is a v. Our v is x plus 1. Again, 1 is a constant, so that means the only one you have any issue with is x. So differentiate this x is also x to the power 1. That means our dv over dx is equal to 1. Then, now, again, what do we need? Formula, we need v. This is our v. Then we need du dx. This is our du dx. Then we need u. This is our u. We need dv dx. This is our dv dx. We need everything in order to solve this particular question. The next thing is to then go to your formula again and substitute. So you have here our dy over dx is equal to v du over dx minus u dv over dx all over v squared. Then so our v is x plus 1 times our du over dx is 1, this one, minus our u is x plus 2, our times now our dv over dx is also 1, all over v squared. V is x plus, so that's x plus 1 squared. And here, x plus 1 times 1 still give you x plus 1 minus x plus 2 times 1 is also x plus 2. I use bracket, especially at the second one, because of the negative sign. If you just leave it as minus x plus 2, then that means you are wrong, because this negative sign has the power to change any sign inside the bracket. If it is minus times minus, will change to plus. If it is plus, minus times plus, change it back to minus. So whenever you have a negative sign before a term, a binomial, or a term that's having more than one, a function that's having more than one term, it is better use bracket like this. So this is over x plus 1 all raised to the power of 2. Then this is x plus 1 minus 1 times x minus x minus 1 times 2, that's minus 2, all over x plus 1 squared. And of course, x minus x is 0. 1 minus 2 is minus 1. That is minus 1 all over x plus 1 all squared. And that is it. Again, I want to quickly go over it. Or move. Okay. So that means here, this is the question given to you. I told whenever you are given a fractional expression, use the quotient rule. This, you should take note that nobody will tell you, use this rule. Most of the questions will just be differentiate this function with respect to x. You have to check the question given to you and see whether you are using the chain rule, whether you are using the product rule, or you are using the quotient rule. Whenever you are given a function involving product of two terms, or two expressions, or two functions of x, use the product rule. Whenever you are given an expression involving quotient, that fractional expression, use the quotient rule. And when you are using quotient rule, please take note. The numerator is u, while the denominator is v. In product rule, any of the terms can be given as u, can be used as u, while the other one becomes v. So now this is the question given. You are given y is equal to x plus 2 over x plus 1. The numerator is u. That's why I put let u be equal to x plus 2. Since u is a function of x, our du over dx is 1. Then the denominator is v. V is x plus 1. Since v is also a function of x, dv dx is 1. Then this is the formula again. So substitute v, this is v, x plus 1, that's it, times du dx, our du dx is 1. Yeah? Minus u, our u is x plus 2, times dv dx, our dv dx is also 1, all over v squared, that's x plus 1 all squared. Yeah. So this is x plus 1, then minus x plus 2 in brackets, all over x plus 1 all squared. So that means x plus 1 is this, minus 1 times x minus x, minus 1 times 2 is minus 2, all over x plus 1 all squared. X minus x is 0, that's why you're having this. So 1 minus 2 is minus 1. So you have minus 1 over x plus 1 all squared. Okay. Omit them. No. So the assignment, you have these 3 questions, and when you do submit the previous one, or that's the question, the first on the last topic, the last class, submit everything now here, shafiru@gmail.com. The submission, you have to submit, today is Thursday, latest by Friday evening. Latest by Friday evening, so I will mark before coming to the class on Saturday. Or most of them. Let me just, maybe just 2 or 3 minutes.
Come.
If you have any question, okay. Okay. Yes, Afis, any question? Any question?
Sir,
Afis Suleiman, any question?
the question I wanted to ask, you have already passed that question. The thing is that,
Okay.
like, after a question, you're meant to ask us whether we understand, because by midway, some of us are lost and won't know what to do, and you have finished like 3 or 4 questions.
Okay, this lesson will be presented on YouTube. Do you have the link already?
Okay.
Hello?
Yes, I'm listening.
So you can go over it again on YouTube. So if there's any question, then you can just send it to this email address given there, shafiru@gmail.com. I will answer your question personally once you send them in. But the lesson, everything is that the Slack will be displayed there on the YouTube. Is that okay?
Yes, sir.
Thank you very much. Yes, Fatih, any question?
Sir, please, can you go back to the assignment?
Okay, the assignment. Well, have you seen it now? Hello?
No, sir. Okay, sir. Thank you, sir.
Okay, then the next slide you have where you have to submit the assignment. Both this assignment and the previous one given to you. Submit everything latest by tomorrow evening, 5 p.m. latest.
Okay, sir.
Thank you. Ikma. Ikma, any question? Ikma, any question? Ikma, any question? Let's go to Arafa. Okay. Okay, Mahfouz. It's okay, they are raising. Maybe.
They are raising and I'm following them.
Okay. Mahfouz. Any question, Mahfouz? Mahfouz, any question? Okay. Adedeji, yes. Yes, Adedeji, any question?
Excuse me, sir. You said we should go to YouTube, but then YouTube, we cannot be asking YouTube questions.
Can you speak louder, please?
Sir.
Fatia.
Sir?
Speak louder. Let me hear what you are saying.
Sir, you said we should go and watch it on YouTube if we don't understand. But then we cannot ask YouTube questions.
Your question, you can post your question on my email. I posted it there, shafiru@gmail.com.
Okay, sir.
Then, okay, yes, just I'll be waiting for your question on it. So we don't have the whole day, so we can't just continue like that. That's it. Nasir, yes. Yes, Nasir, any question? Nasir, any question?
Yes, I have a question.
Yes, I'm listening.
You were too fast when you were telling us when to use the quotient.
Can you speak louder?
You were too fast when you were telling us when to use the product or quotient rule. Can you please like go over it again? I couldn't hear you.
When you use the quotient rule, whenever you are given a fractional expression, any question that's given in terms of in form of a fraction, use quotient rule. The quotient means the outcome of dividing a term or a function by another one. And whenever you are given a function and a question involving product of two terms, product means the outcome of multiplication. Once it involves multiplication of a function of x by another one, use the product rule then.
Okay, sir. Thank you, sir.
Okay, thank you.
Yes.
Thank you. Okay. Okay, yes, it's Salami. Yes, Abdullah, any question?
I just want to confirm when we want to send the assignment.
You said?
When we want to send the assignment.
My mail, shafiru@gmail.com.
We should take the picture of what we wrote.
You can solve on a piece of paper, take picture and send there because to type might not be easy for you. Do you understand that?
Yes.
All right, thank you.
Yes, sir.
Okay. Thank you all. Let me speak with all of them now. Okay, thank you all. Like I said, the assignment solve on the piece of paper and start send to the team. You might not be able to type because mathematical science there. Solve in your notebook, snap, send to my team. That's really a
I have a question.